Hello, viewers. Welcome once again to episode 20, still on the static mechanic. We are picking the resultant forces from, I think, the last 4 episodes. That is what we are treating. So now we are on the second aspect. The first aspect was resultant of coplanar, of concurrent forces acting on a point. So they are all acting from a particular point. The second one is when we are having a resultant of a system of coplanar forces, forces on the same line. That's a coplanar. All right. So this resultant of this system of force in a coplanar forces acting at a point is equal to the vector sum of all the forces. So there are 10 forces. The resultant of all those forces become the vector addition of all those forces. So if the forces F1, F2, F3 to infinity act on a body P, then the resultant of all the forces R is going to be given by resultant of the forces equals to the vector. This is just the vector force 1, vector force 2, adding all of them together. Then note, first resolve if the force is given to you in the magnitude bearing form. You must resolve into column vector. Resolve into column vector or into Cartesian coordinate form. That is the idea we are going to be dealing with. So the new concept here is we are adding the resultant forces. The previous concept is to use the cosine and the sine rule to find the resultant and the angle between them. So this is the only difference between the first and the second one. So now let's look at a question. A body of mass 500 gram lying on the horizontal floor is acted upon by forces 1, 2, 3, 4. 1. We are to express all the forces acting on the body as a column vector. You see, moving from here to the column vector. Then 2. Find the magnitude and direction of the resultant vector. So it means that after translating all these forces into vector column form, we need to add all of them to find the resultant. Then we can check the previous episode how to find the direction using the column vector force. All right. Then the last one is to find the magnitude and direction of the resulting acceleration. So this is resulting acceleration. So here we are finding magnitude and direction for the acceleration and magnitude and direction of the resultant force. Let's get into that. If I pick the first example, which is the A part, finding the force. If I have force 1, which is 10 Newton in the direction of 90 degree, force 1 will be equals to the magnitude 10, the sine of the angle, degree, for the x component, then cos of the angle 90 degree for the y component. We discussed this in the previous episode. So 10 times sine 90, we can use our hand, but to move fast, let's use the calculator. So if you do that, this is giving 1. 1 times 10 will be 10. Cos 90 is 0, so we have 0. Then we have for Newton. Let's go for force number 2, which is also 16 Newton in the direction of 180 degree. That makes the vector column force to become 16, the sine of 180, 16, the cos of 180 degree. Let's put all in our calculator and see what we will get. All right, so sine 180 is 0. So we have 0 times 16 being 0. Cos 180 is negative 1. So we have negative 16 Newton for the second force. Let's go to the force number 3, which has magnitude to be 8 Newton, direction to be 30 degree. So force number 3 will be given by the 8 sine 30 degree, 8 cos 30 degrees. Let's see that. So in the first one, this is half, so we have half times 8 is 4. This is multiplied by this, give you 6.9 as the y component. So these are the vector component of the first three forces. Let's take the fourth one. So from here, the fourth one will be the F for 12, the sine of 300 degree, 12, the cos of 300 degree. You put this in the calculator direct and see what that will give us. So the first part will give you negative 10.4. The second part will give you 6. All these in what? Newton. So you can see that we have the first part of the question asking for vector column position form of all the four forces acting on that body. The next one is to find the resultant what? Forces. So let's see. So the resultant forces are, which we know will be given by the force 1 plus force 2, force 3, and what? Force 4. So this, the first force is 10, 0. The second force is 0, negative 16. The third one is 4 and 6.9. And the last one is what? Negative 10.4 and what? 6. So we are going to add all those things. So we add them in linear form. Okay, let's see. 10 plus 0 plus 4 minus 10.4, 0 minus 16 plus 6.9 plus 6. Let's see the value of that. So if we add the first one, we should be having 3.6 and the second one negative 3.1. So this is magnitude, so we can indicate our Newton. Now, the first part, we find the forces in vector column. Second part, we are finding the magnitude and the direction. So now we know the magnitude of the resultant force. We need to know the direction. I'll be taking care of this also. This is looking for magnitude and direction for resulting what? Acceleration. So let's take care of this and see the next step. So from here, therefore, okay, let's just see the magnitude of R is, let's say, given by, so magnitude of R equals to the root of X component, 3.6 all square, Y component, negative 3.1 all square. Let's put that in our calculator. This will be 3.6 times 3.6. That will give you 12.96. Negative 3.1 times negative 3.1. That gives us 9.61. Let's add all of them together and see. So this will give you 22.57. Let's put this in the under the root and see. 22.57. That will be giving you, let's do 1 decimal please. So 4.8 resultant. So we have for Newton. So this is going to be the magnitude of the force. Then looking for the direction. So for the direction, remember we talked about all this, I think in episode 17 or so. We have this. Picking the component. This is the X component. This is the X component. And this is what? The Y component. So for the X component, we are moving on the positive lane. for the y component moving what? Negative lane. So I should have the point here and the point here, the center being here. The angle it formed with the x-axis, this will give you 90. The distance here is a 3.6. The distance here is a 3.1. The negative is only showing the direction of the y-axis. If it is positive, we are going this way. Negative means this. We are only picking the distance created there. So looking at that, what are we looking for? This angle. So I can say that the angle will be tan theta equals to the opposite side 3.1 divided by the adjacent 3.6, making theta equals to the tan inverse of 3.1 over 3.6. So that makes your theta should be equals to, this is going to be 40 point I think 73. So let's use one decimal places, and that is it. Now this angle we are seeing here is not the actual distance or actual bearing or direction. The actual bearing or direction is moving from the north, including this. So let's indicate that. We can say that the actual direction measured from the north is going to be from here to here is 90. So I have 90 degree plus 40.7 degree equals to 130.7, which I can take as 131 degree. So therefore the resultant R is going to be what was a magnitude 4.8 Newton. Then the angle is 131 degree. So we have the magnitude. It's a find the magnitude and direction. So the magnitude is 4.8, or better still 5 Newton. If you are doing whole number, then 131 degree as what? The bearing. I guess the procedure is clear for you. If no, you can leave a comment in the comment section. Now, what are we looking for the last one? We are looking for the magnitude and direction of the resulting acceleration. Remember, resultant force is a force. So resultant, I just have to use the formula. No need to explain that. Let's say the resultant will be equals to the force, the mass of the body times what? The acceleration. So this is the resultant, which is like a force. A force equals to the mass times what? Acceleration. But we are looking for the magnitude of the acceleration, right? It means if I find the magnitude of the resultant force, that should be the same as what? This. I don't know if I'm explaining the concept. Let's say I can say that from here, A will be equals to resultant over what? M. Is that not it? If we are to do that. So this is just the acceleration. But how about the magnitude of the acceleration? So magnitude of the acceleration will be equals to the magnitude of the resultant force over what? The mass. And the mass will always be the mass. No need finding the resultant of the mass. Alright. What was the mass? We know the mass was 500 grams, which is the same as what? Divided by this will be 0.5 kg. So my acceleration will be magnitude. What was the magnitude? 4.8 divided by 0.5. I guess let's check on the calculator. Okay, if we check on the calculator, it should be 9.6, and acceleration. So this will be meter per second square. So therefore, acceleration will be the magnitude, which is 9.6 meter per second square, then 131 degree. Remember, the acceleration is just on the same force where the force is. So when the force is here, the acceleration is just looking at the speed, right? The movement here. So the acceleration is happening here. It cannot happen here, whilst the force will be happening here. So the angle of the force will be the same as the angle of what? The acceleration. Whenever the force is taking place, its acceleration also will take place in there. I guess with the three sub questions on this particular question, explain all the areas that the question, the finding the resultant force of any coplanar forces that are not acting from a point that are making an angle. I think the concept will be well understood by you. Share the video, comment with your thoughts, like the video, and subscribe.